Now, in today's class, let us get started with probability SAQs. So, the fourth question is find the probability of drawing an ace or a spade from a well shuffled pack of 52 playing cards. So, before moving on to the solution, let me tell you about the cards. So, there are 52 cards, out of which 26 are red, 26 are black. Now in 26 red, again you have 13 hearts, 13 diamonds. And in this 26 black, you have 13 clubs, 13 spades. And in each design, you have 13 cards. And those 13 cards are A, 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, King. Jack, Queen, King are face cards. So now let's move on to the problem. Find the probability of drawing an ace or a spade from a well shuffled pack of 52 playing cards. So let us say S be the sample space. Total number of cards in the pack is 52. So what is N of S? N of S is from 52 cards, you are drawing one card because an ace or a spade is given. An or a means one. So from this 52 cards, you are selecting any one card. So N of S is 52C1. That is 52. Now if A be the event of getting an ace card, then N of A is equal to how many ace will be there in a pack of cards? In each design, you have one ace. So there are 4 designs. So 4 ace will be there in a pack of cards. So this is 4C1. From these 4 ace, we are selecting any one. That is 4C1, which is equal to 4. If B be the event of getting a spade card, now how many spades are there in a pack of cards? So we take N of B is equal to, spade is a design. So one design has 13 cards. So 13 spades are there. From these 13 spades, we are selecting one card. So that is 13C1, which is equal to 13. Now what is probability of getting an ace card? Probability of getting an ace card is, ace we have taken as A. So P of A is equal to N of A by N of S. So that is 4 by 52. And what is the probability of getting a spade card? P of B is equal to N of B by N of S. So how many spades are there? 13 by 52. Now you see A union B is common. Common to both the events, A and B. So where do you get a combination of spade and ace? There is only one spade ace. There is a spade ace. In spade design, you will have only one ace. So N of A intersection B is equal to 1C1. There is only one spade ace. From that, you have to select one only. So the answer is 1. So what is probability? probability of getting A intersection B is P of A intersection B is equal to N of A intersection B by N of S. That is 1 by 52. Now what do you have to find? The question is asking you for find the probability of drawing an ace or a spade. Or means union and means intersection. So that means they are asking you for union. So probability of getting either spade or ace is P of A union B. Now we need to find out P of A union B. So we use addition theorem here. See, we have P of A, we have P of B, we have P of A intersection B. So we can easily find P of A union B by using addition theorem of probability. So what is addition theorem of probability? P of A union B is equal to P of A plus P of B minus P of A intersection B. So P of A is 4 by 52. P of B is 13 by 52 minus 1 by 52. So that is 4 plus 13 minus 1 by 52. 4 plus 13 is 17. 17 minus 1 is 16 by 52. That is 4 4s are 16 and 4 13s are 52. 4 by 13 is the answer. Make a note, this last problem is very, very important. Now let's move on to the next question. This is also very, very important. Suppose A and B are independent events with P of A is equal to 0.6, P of B is equal to 0.7. Then we have to find these 4 bits. So here we will use independent events. So A and B are independent events. Independent events means change in the first event will not affect the other. So whenever A and B are independent events, then you can take P of A intersection B is equal to P of A into P of B. This is the condition for independent events. P of A intersection B is equal to P of A into P of B. Now what is given to us? P of A is equal to 0.6. P of B is equal to 0.7. Now number 1. P of A intersection B is equal to P of A into P of B. So that is 0.6 into 0.7. 6 sevens are 42. Now after decimal you have 1 digit. Here after decimal you have 1 digit. So total there are 2 digits after decimal. So before 2 digit you put a point. So this is 0.42. Now number 2. P of A union B. Now you have P of A, you have P of B, you have P of A intersection B. Now we can use addition theorem for P of A union B. We know that P of A union B is P of A plus P of B minus P of A intersection B. So P of A is 0.6 plus 0.7 minus 0.42. 0.6 plus 0.7 is 1.3. See, we can add here 0.6 plus 0.7 is 7 plus 6 is 13.1. Now from 1.3 we subtract 0.42 minus 0.42. Now see how to subtract 0.42. Wherever you have a blank you can put a 0. Now here 0 becomes 10, 3 becomes 2. 10 minus 2 is 8. Now again borrow. This will become 12. This will become 0. 12 minus 4 is 8.0. So this is 0.88. Now next third bit is P of B by A. What do you mean by B by A? Whenever you have one event by some other event, that means it is conditional event. So P of B given A, which means we already know that A has occurred. Now we are checking for B. So the formula for P of B by A is P of A intersection B by P of A. Already we found P of A intersection B in the first bit. Or we can do in one more way. P of A intersection B can be written as P of A into P of B because they are independent events by P of A. P of A cancel. We know that P of B is 0.7. And fourth bit is P of A complement intersection B complement. So this can be written as P of A union B whole complement. So that is 1 minus P of A union B. See, whenever you want to find out A complement, it is 1 minus A. P of A complement is 1 minus P of A. Okay, P of B complement is 1 minus P of B. Same way, P of A union B complement is 1 minus P of A union B. This formula I am using now. Okay, so that is 1 minus P of A union B. We got P of A union B as 0.88. Now we need to subtract 1 minus 0.88. I'll show you how to subtract. 1 can be written as 1.00 minus 0.88. Now we borrow. 0 becomes 10. This 0 becomes 9. This 1 becomes 0. 10 minus 8 is 2. 9 minus 8 is 1. This is 0.12. Or directly you can do 100 minus 88 is 12. So it is 0.12. Both the ways are correct. Now take the next question. This question is very, very important. Last appeared in AP March 25. So let's see how to begin this question. So whenever you find independent events in the question, always remember the condition. Since A and B are independent events, what is the condition? P of A intersection B is equal to P of A into P of B. Now, what is given to us? P of A is equal to 0.2. P of B is equal to 0.5. Now first bit, what is P of A by B? A by B means B has already occurred. You are checking for the probability of A. So how do we read this? P of A given B. Formula is P of A intersection B by P of B. In the denominator, what letter you have? The same letter will come here. P of B. So, because they are independent events, P of A intersection B can be written as P of A into P of B by P of B. P of B cancel, that is P of A. But P of A is given as 0.2. Now second bit, P of B by A. What is the formula for P of B given A? P of A intersection B by P of A. Again, this can be written as P of A into P of B by P of A. You can cancel P of A and finally you will be left over with P of B. But we know that P of B is 0.5. So this is the value for the second bit. Now moving on to the third bit. Third bit is P of A intersection B. I already told you P of A intersection B condition is P of A into P of B. So that is we need to multiply 0.2 into 0.5. 2 into 5 is 10. After decimal 1 digit, after decimal 1 digit, total 2 digits. So before 2 digit we place a point. So this can also be written as 0.1. This is the third bit. Now we need to do the fourth bit. Fourth bit is P of A union B. Now see, look at the question. You have P of A intersection B, P of A, P of B. So we can easily find P of A union B using addition theorem of probability. What is addition theorem of probability? P of A union B is equal to P of A plus P of B minus P of A intersection B. But we know P of A and P of B. So let us write P of A intersection B as P of A into P of B. So now we are substituting P of A and P of B values. So 0.2 plus 0.5 minus P of A intersection B, you got it as 0.1. So 0.2 plus 0.5 is 0.7. 0.7 minus 0.1 is 0.6. This is the answer for the fourth bit. Now take the next question. This question is also very, very important. It last appeared in TS March 2024. If A and B are two events with P of A union B is equal to 0.65, P of A intersection B is equal to 0.15, then find the value of P of A complement plus P of B complement. Now you see here A and B are two events given. Independent events are not given. Simply events are given. Okay. Now what is given to us? P of A union B is equal to 0.65. P of A intersection B is equal to 0.15. Now from addition theorem of probability, what is addition theorem of probability? P of A union B is equal to P of A plus P of B minus P of A intersection B. If I take this minus P of A intersection B to the left side, we can write P of A union B plus P of A intersection B is equal to P of A plus P of B. So we get P of A union B is 0.65 plus 0.15 is equal to P of A plus P of B. So P of A plus P of B is, what is 65 plus 15? It is 80. So this is 0.80, or simply we can write it as 0.8. Okay, now what they are asking us for? They are asking us for P of A complement plus P of B complement. As I told you in the last problem, P of A complement can be written as 1 minus P of A, and P of B complement can be written as 1 minus P of B. So 1 plus 1 is 2. If I take minus common, we can write P of A plus P of B. But from this step, if you see, P of A plus P of B is 0.8. So we can write 2 minus 0.8. That is 1.2. So I'll show you how 2 minus 0.8 became 1.2. So 2 is 2.0 and 0.8. Now borrow. 0 becomes 10, 2 becomes 1, 10 minus 8 is 2, 1 minus 0 is 1. This is how you got 1.2. Understood?